Okay, we are going to take a look at converting fractions to decimals. So up to this point, by 8th grade, all of the numbers that you have encountered in school can be classified as rational or irrational. So before we start converting, we need to talk about what these numbers are. We're going to focus on a rational number first. So an irrational number is any number that can be written as a fraction. So any number that you could write as a fraction doesn't mean it has to be written as a fraction, but if you could write it as a fraction, it's a rational number. Now today we'll be looking at taking something already written as a fraction and converting it to a decimal. So we are actually going to be dealing with rational numbers today. Okay, so we'll be given the fraction. So everything today will be rational, and any rational number can be written as a fraction. So for example, if I gave you the number 4, to write 4 as a fraction, you would write 4 over 1. There are certain decimals, and we'll look at this when we convert decimals to fractions, but there are some decimals, and if you can take that decimal and you could write it as a fraction, it's also a rational number. So with the fractions that we're going to be converting today, we're going to be converting them to decimals. There are two types of decimals that we're going to encounter. The first type of decimal is a terminating decimal. So we need a definition of that. Terminating means to end. If you're terminated from your job ends. The official definition we want you to have, though, is a decimal with a finite number of decimal places. Now, there is one word that you may be struggling with, the word finite. Finite means like a specific amount or an amount that ends. So if I were to replace that word finite with an amount that ends, okay, a specific amount, let's say the number 3. So if I replaced the word finite with 3, and I read it, a decimal with 3 decimal places. That's an ending amount. The decimal ends. Okay, so a decimal with a finite number of decimal places, another way of saying that is a decimal that ends. Okay. Oops. So this could be more of a simplistic definition for you, This blue definition, however, will be what you would need to know, the official definition. So an example of what this would look like, 231 thousandths. My decimal ends. There's nothing else happening at the end. 7 8/10. The decimal ends. It has a finite number of places. This decimal has 1 place after the decimal point. This decimal has 3 places after the decimal point. Our next type of decimal is a repeating decimal. Most of you have heard of a repeating decimal before. Decimal that has a digit or block of digits that repeat. Now, there's a very specific reason that we put that or, and I'll explain what I mean in a second. So if we look at the first part of the definition, a decimal that has a digit that repeats, that could be an instance like this. 33 or 0.33333. That would be where just a digit repeats. You could even have something like this, 72 with the 5 repeating. The digit that's repeating is the 5. One thing that you'll notice with these types of decimals is you'll see the 3 dots at the end. If you do not see 3 dots at the end, that means the decimal has terminated. Okay, so these little dots signify that the numbers keep going on forever. So the numbers go on forever. That's what those little dots signify. So now if I look at the second part where it says block of digits, what that means is you don't always have the same exact number repeating and just that number repeats. You could have something like this, 2.1313. These 3 little dots tell me that the numbers go on forever. And the number that's repeating is my 1 and the 3. So this is what they mean by block of digits. Here's another example, 0.456456. I know it's repeating because I have my decimal my decimal points, or I have the 3 dots that come at the end. And my block that's repeating is the 456. So in case you need a little review, the way that we write these decimals is wherever the repeating happens, we end up drawing a line over the decimal. This bar goes above the digits that are repeating. For my purple numbers, when you have a block of digits repeating, you write the block and you put the bar over the entire block. So again, the bar goes over the entire block. Once in a while, you'll have a decimal where things don't repeat for a few, and that's where that bar comes in handy. All right, let's take a look at some examples. There are 2 ways that you can convert fractions to decimal. Okay, the first method only works once in a while, but it's actually a really quick one. So the first method is to make equivalent fractions and what you want is this equivalent fraction is going to be with the denominator as a power of 10. If you don't remember what a power of 10 is, 10, 100, 1,000, 10,000. Those are examples of a power of 10. So let's take a look at one. First example, 1/2. So I'm going to create an equivalent fraction. Now, if you had to simplify a fraction, you would divide something by the top and the bottom. You would divide a number by the numerator and divide by the denominator. The only thing is this fraction is simplified. And I need my denominator to become a power of 10, which is actually bigger. So if you want to take your fraction and create something equivalent where the numbers are larger, now remember, because we're making them equivalent, the values aren't changing. I need to make the numerator and the denominator larger to create this equivalent fraction. So what we want to think of is, I want to think of, is there something I could multiply by 2 that would give me a power of 10? Is there something times 2 that equals 10? Or 100? Or 1,000? I'm hoping you said 2 times 5 equals 10. That's a power of 10. If I multiply the numerator by 5, I must multiply the denominator by 5. I multiply the numerator by 5. Let's actually turn those into a better symbol. 1 times 5 is 5. So what happened was, although the 5 and the 10 are larger numbers than 1 and 2, the fraction's actually equivalent. 1/2 equals 5/10. And what's nice is when you read this fraction correctly, if you don't say 5/10, if you actually say 5/10, and you say 5/10 to yourself again, and you think about the word 5/10 as a decimal. So if I were to tell you, write 5/10 as a decimal, what would you write? Hopefully that's what you thought. You could put the 0 in front or not. Writing it out in words while you're practicing is not necessary. What is necessary is if you have a denominator that's a power of 10, you should say that fraction to yourself correctly, and the decimal just kind of happens. It's pretty cool. Let's look at another one. Example number 2, 7/25. So now we need to think, does 25, can I multiply something by 25 that will get me a power of 10? 10 won't work, it's too small. This fraction can't be simplified. What about 100? Hopefully you thought 25 times 4 equals 100. 7 times 4 is 28. My fractions are equivalent, but now I have something with a power of 10 in the denominator. Now, if I were to think about this fraction and say it as a fraction in the correct vocabulary, I would say 28/100. So I would say 28/100. Say that to yourself a couple times and try to picture the decimal. Just in case you don't remember how to write decimals with the wording, the digits, basically whatever place you say. So we have tenths is the first place, hundredths is the second place. So since I'm in the hundredths, I know my decimal will end here. I just so happen to have 2 digits, so my 2 digits just fall in line. But usually whatever wording, tenths, hundredths, thousandths, that shows you how many digits happen behind the decimal. So on a side note, if it was 3 hundredths, okay, if my fraction was 3 hundredths, what I would do to make my decimal is I know hundredths is the second place after the decimal. So I take my digit 3 and I put it in the hundredths place. There's nothing in the tenths place, so I put a 0. And this is a little bit of a side note here. The other way you could look at this, if we look at our numerator, my numerator are the numbers behind the decimal. I have 2 zeros in my denominator, so I have 2 place values after the decimal. In 3 hundredths, 3 is the digit I'm using. 100 has 2 zeros, so my 3 is 2 digits behind the decimal. Now let's say you don't feel like trying to convert to 100 or 10, or you can't convert. The second method works all the time. It's just that once in a while method 1 is a little faster. It might be, it might not be, but method 2 always works. Method 2 is to divide. Divide the numerator by the denominator. Now, a lot of times students have trouble deciding what order that is, what number is underneath the division symbol, what number is outside. So if we had if we had A over B as our fraction, we divide the numerator by the denominator. So that looks like this. A divided by B. Now you might be saying, well, that doesn't tell me what number goes inside and outside, which is usually the first question students ask. If you write this like you read it, A divided by B, A divided by B, the number being divided goes inside the division symbol. So what I usually do is that I write it as I read it. A divided by B. But I always wrote the number being divided first. If you think about it, you read it first as a fraction. You read it first if you have this written as a division problem with this division symbol. Same thing here. A divided by B. My numerator goes inside your division symbol. So let's take a look at an example. We're calling this example 3 because it's the third example of the overall lesson. So our first example for method 2 is 3/8. Unless there's some crazy number I'm missing or would take forever, to try to make 8 become a power of 10, way too much time am I going to spend trying to figure that out. So we use method 2. I'm going to convert this to a division problem, 3 divided by 8. Numerator divided by the denominator, 3 divided by 8. So a little review on long division. Nothing times 8 equals 3. That's a whole number. So I write my decimal and I place a 0. I can't change the value of this number inside to 30. It has to stay 3. So in order to get enough digits to divide, I have to include a 0 at the end. Bring up your decimal. 8 times what gets us close to 30 without going over? I hope you said 3. 8 times 3 is 24. I subtract, I get 6. I can use another 0 so that I can bring that 0 down and continue to divide. Remember, I'm not changing the value inside. 8 times 7 is 56. Gets me close without going over. Bring my 0 down. 8 times 5 is 40. So my answer is 375 thousandths. 375 thousandths. Now, I did create a decimal, and it's in the thousandths, so I could have done the conversion and turned 8 into 1,000, but again, that would take so long. This method, in this case, is faster. Next example, number 4. 1/12. I'm going to divide and say 1 divided by 12. When I write my division problem out so that I can do my long division, it's 1 divided by 12. Write your decimal, and let's include a 0. There's nothing times 12 that equals 10. Now I know it's 1.0, but since I brought that decimal up, I can ignore it right now and just focus on the digits. Nothing times 12 gets me 10, so I place a 0. Give myself another 0. What times 12 gets me close to 100 without going over? It's 8. And 12 times 8 equals 96. Subtract, I get a 4. 12 times 3 is 36. It's as close as I can get. I have a 4 left over. What you should start noticing is that my result here is repeating, and if your result is repeating, your decimal ends up repeating. Because now I've got a 3 again. I'm going to go through the vicious cycle of continuously subtracting 36 and getting 4. So at this point I can stop. I know this is going to go on forever. So the way I write my final answer is I'm going to include my 0 and my 8. Those are not repeating. The only part that's repeating is the 3. So I write the first 3 and I put my bar over the top to show that the 3 repeats. Now our last section is guided practice. With these questions, I will give you a problem. I want you to try it on your own. So you'll hit pause, try it on your own, and then you'll check with me. So our first guided practice problem is 4/11. So hit pause, try this on your own. Let's see if you can get it. Okay. Hopefully you looked at this as 4 divided by 11. When you wrote out your long division, you did 4 divide by 11. Add in your decimal and a 0. I'll go ahead and start working this through. Follow along with your work. Make sure if you have any errors, you pause, see where you are different than me. That way you can identify what happened. What you should have noticed is I have some things repeating here. My 3 and my 6. And you may have even seen as you were working that you had 40, 70, 40, 70. If your work starts repeating, there's a very good chance your decimal will too. Actually, you can pretty much bank on it. So the 3 and the 6 are both repeating. That's where my repeating bar goes. And there, that should be your answer.